In this video, I just wanted to give some examples of graphing from factored form, and then uh, show how I can come up with all the information that I need and draw an okay sketch of it by hand, and then compare that with what Desmos does. So let's look at an example. Let's say that I have y equals x minus 3 times x plus 1. The first thing that jumps out to me are the 3 and the 1. And I know that a couple important points are x-intercepts and y-intercepts. So for an x-intercept, you want to get an answer of 0. So you're asking yourself, what x number gives me an answer of 0? And I can tell that if I make x equal 3, 3 minus 3 gives me an answer of 0. And over here, if I make x equal -1, -1 plus 1 gives me an answer of 0. And I also know that if I multiply two numbers, and if one of those numbers is 0, I'm going to get an answer of 0. So what I mean is 5 times 0 is 0. 0 times a million is 0. Anytime you have a multiplication problem where one of the numbers is 0, you're going to get an answer of 0. And so that's why when you have factored form, you're able to just look at one of the numbers at a time, because you only need one of them to be 0 for the whole answer to be 0. If you want to be fancy, that's called the zero product property. If you don't want to be fancy, you just need to remember, look at the parentheses. What makes the parentheses equal 0? Do not think that because you see an x minus 3 that you're going to put a dot at -3. You put a dot at the opposite because you're making the parentheses equal 0. You're getting an answer of 0. So I plug in x equals +3. I know that's going to be one of my x-intercepts. I plug in x equals -1. I know that's going to be the other one of my x-intercepts. Okay? The next thing I do is, instead of getting an answer of 0, I'm going to plug in x equals 0. If I plug in x equals 0, then I don't know what y is. So I'm going to say 0 minus 3 times 0 plus 1. 0 minus 3 and 0 plus 1 are pretty easy to calculate, just -3 and 1. And we're multiplying those together, so we get y equals -3. I put a dot right down there. The last point, that is probably the hardest point to find, is the vertex. But I know that the vertex is halfway between my x-intercepts. So to find out halfway between x-intercepts, I can add them up and then divide by 2. 3 plus -1 is 2. 2 divided by 2 is 1. So I know that at x equals 1, somewhere along this dashed line that I just drew, I'm going to have the vertex. This is an x value. So I'm going to take that x value and I'm going to plug it in to find out what y is. 1 minus 3, 1 plus 1. So that's -2 and +2, giving me -4. That's a y value. So now I can put my vertex dot down there at 1, -4. With those dots in place, I can draw a pretty good, I say I could draw a pretty good thing and then I missed the dot. I can draw an okay parabola. And let's look at what Desmos does when it graphs it exactly. Y equals x minus 3. Notice that x minus 3 went through x equals 3. Now x plus 1. And yeah, pretty darn good. So obviously my curvature is not perfect, but I got my x-intercepts in the right spot, I got my y-intercept in the right spot, I got my vertex in the right spot. That's pretty darn good. Let's look at one more example. Let's get rid of that. Let's do one that's a little bit harder. Something like y equals -1/2 x, x plus 5. So this might look a little different. You might notice that there's only one set of parentheses. You might notice that there's a negative fraction involved. Same steps as before. I'm going to look at what makes one part of the problem equal 0 and what makes the other part of the problem equal 0, and those will be my x-intercepts. So if I look right here, I'm thinking, what makes -1/2 x equal 0? You can literally write that down as an equation if you like. What makes -1/2 x equal 0? Well, I don't like that fraction, so let's multiply both sides by -2, and I get x equals, well, 0. 0 times anything is 0. That's one of my x-intercepts is x equals 0. When I look at this other piece, x plus 5, I can write down the equation, or you can probably just get it in your head. If x plus 5 equals 0, you know that x equals negative 5 is your x-intercept. So there's 0, there's negative 5. Those are my two x-intercepts. I already know the y-intercept also. It happened to double up as my x-intercept. If you don't notice that, that's okay. You don't need to notice that. You can just plug in 0 for the x values and follow the exact same steps that I did before. 1/2 times 0 is 0. 0 plus 5 is 5. 0 times 5 is 0. So it just confirms what we already knew. The last part, and the hardest part, is the vertex. So I add my two x-intercepts because the vertex will be halfway in between them. 0 plus 5 is 5, and then I divide by 2 to get halfway between. I get 2.5 as my x value. And I just made a mistake. I hope you see what mistake I made. I added the 5, which was the number from the equation. I should have added the negative 5, which was the x-intercept. The way that I caught my mistake was I looked at 2.5 and I thought, wait a second, how the heck could the vertex be over there? That doesn't make sense. It's not in between. So then I checked back and I realized, oops, I should have added negative 5, making this negative 5 over 2, making that negative 2.5. So it's okay to make mistakes. Just make sure that you are checking, do my answers make sense as you go throughout the problem? So there's negative 2.5. If I plug in negative 2.5, I'll get the y value of the vertex. I suggest grabbing a calculator for this. You got fractions, decimals, you got a lot of action going on here. So I'll show you how it should look when you type it into your calculator. Let the calculator do the annoying work for you. You're doing the hard work. You're doing the stuff that's all the thinking. The calculator's just doing the annoying work. There we go. Negative 1/2, negative 2.5, negative 2.5 plus 5, 3.125. I didn't feel like calculating that in my head. 3.125. All right, so 3.125. I'm not going to get that perfect. It's something like that. So there's my vertex, negative 2.5, 3.125, and just dropping that parabola through there. And let's compare to how Desmos graphs it. I bet my curvature is a little bit off, but that's okay. Notice how when I type in negative 1/2 x, it goes through that corresponding x-intercept. When I type in x plus 5, it goes there. So yeah, my curvature was a little bit off, but I got my 3 anchor points in the right spot. So thanks for watching. Let me know if you have any questions, and I'm happy to help out.